Topics of the day. In this session, we will understand pointers which play a very crucial role in programming. Pointers in programming are variables that store memory addresses. They provide a way to manipulate and manage memory, enabling more efficient and flexible programming. Pointers empower programmers with the ability to directly manipulate memory, offering efficiency, flexibility, and foundation for dynamic memory allocation, intricate data structures, and optimized algorithms in programming languages like C and C++. So, in this session, we will understand the basics syntaxes of pointer variable in C programming. In this flow, we will first introduce the pointers are variables that are used to store memory addresses. We will see the syntaxes and then we will see how pointers play a very important role in efficient memory management. How do we declare pointers? Pointer declaration involves specifying a data type the pointer will point to, followed by an asterisk symbol. So here is an example of declaration declaring a pointer. Int star ptr declares a pointer to an integer named ptr. So how do we assign values to the pointers? Is using the address of operator. We will see an example program to understand how to declare and initialize a pointer. So let's go to the example program to understand declaration, initialization, and dereferencing of a pointer. PTR here refers to the pointer of type integer. Star is the operator or symbol that is used to indicate that PTR is a pointer variable. We have an integer data called as num whose value is equal to 52. The address of this num is assigned to a pointer variable. So now if I want to print the content of PTR, which is nothing but, see, the content of PTR is a address whose format specifier is given as percentage %p is PTR. So now we will be able to see the address of variable num. So this is the content of this PTR. So this could even be done if we have a variable which is defined before the pointer declaration. The assignment of the pointer can be done during its declaration as well. So now num is an integer data whose address is assigned to PTR. So now when we run this code, we will be able to see the address of this number. Now let us assume I want to assign a value 5 to this variable num using the pointer. We use a technique called as dereferencing, which is done by using a dereferencing operator asterisk. Dereferencing is the process of accessing the value stored at memory address pointed by this pointer. Here is an example. X is a data whose content is 0. T is a pointer. We have the address of X in pointer T. When I use the dereferencing symbol across this P and assign it to 5, it means that we are accessing the memory location that is 1004, which is named as X. which changes to a value 5. So let's look at an example. So in the previous example, now let's say I want to assign PTR is equal to 10. So star PTR refers to the content of that memory location. Now if I try to print the value of num, because it is updated using the pointer, you will be able to see the value that is 10. So we can see that the num is having a value 10. So in the same way, it is also possible to use a star symbol in the print statement as well. So the points to note here is how to declare a pointer, how to initialize the pointer with the address of a variable, and how to dereference it to get the content. The point to note here is there should always be a type match between the pointer and the data to which it points. Now let's assume if I have a char data and I am trying to assign the address of that to an int pointer, it would result in an error. It is always essential that we match. See, we can see that there is a warning that shows that they are incompatible. Next, let's understand what are null pointer. Null pointer is a pointer that does not point to any memory location. It is typically assigned to a value null, 0, to indicate that it is intentionally uninitialized or doesn't refer to any valid memory address. Null pointers are commonly used to signify that the pointers does not point to any valid object or functions. They help in preventing accidental memory access and provide a way to check if the pointer is valid before attempting it to dereference. So it's always a good practice to initialize the pointers to null when they are declared. Before dereferencing, it is always advisable to check whether it is a null pointer to define undefined behavior. It is also good programming practice to return a null pointer to indicate any absence of results in functions. Let's understand the relationship between pointers and arrays. The name of an array is pointer to that array. It means that the name of an array points to the first element of the array. This allows the array names to be used as pointers interchangeably. Pointers and arrays can be used interchangeably using the pointer arithmetic. Incrementing the pointer helps us in accessing the next element in an array, which facilitates efficient navigation. When an array is passed to function, it is the pointer that is passed that is the address of the first element. The functions receive pointers as arguments, enabling to work with arrays of varying sizes. Pointers are used in dynamic memory allocation, which allows us to create arrays of sizes that are determined during runtime. There are special functions in C programming to help this dynamic memory allocation that return pointers which contains the address of dynamically created memory. Finally, pointers to arrays are used to represent multidimensional arrays. To navigate 2D arrays, pointers offer more flexibility. To summarize, pointers and arrays are closely related and they help in efficient programming. Now let's understand what is the relationship between pointers and functions. Function pointers allow the storage and manipulation of addresses of functions. We know that the functions are also stored in the memory. They provide a way to create flexible and generic function interfaces. Function pointers are used to implement callback mechanism. When a function pointer is passed to another function, dynamic execution is possible. Sometimes it is possible that different functions are to be executed, which is decided during the runtime. C supports to create array of function pointers that allows the management of multiple functions, facilitating the tasks such as building function dispatch tables in higher order systems. Function pointers also help in achieving polymorphism in C. A program can select and invoke functions at runtime, enhancing flexibility and adaptability. Finally, dynamic function calls are possible using function pointers. The ability to change which function is called during the runtime enables dynamic and extensible systems. The next application of pointers is in dynamic memory allocation. Pointers in C facilitate dynamic memory allocation, allowing adaptable storage utilization during the program execution. Pointers contribute to the efficiency and versatility of C programming by dynamically adjusting to the changing data needs. Proper handling, proper handling of pointers is very essential to prevent memory leaks and undefined behavior, ensuring robust and reliable program execution. So, dynamic memory allocation ensures effective memory utilization, which requires pointers as their basics. What are the common pitfalls while using pointers? First one is null pointer dereferencing. If we try to dereference a null pointer because it doesn't point to any memory location, we will not be able to get any value. The next pitfall is failing to free a dynamically allocated memory using the free can result in memory leaks and can degrade the program performance. We will discuss in detail about this memory leak in the upcoming slide. A while pointer is a pointer that is not initialized or initialized with any arbitrary or indeterminate memory address. It can point to any memory location, including the areas that may not be a part of program's allocated memory. Using or dereferencing a while pointer can result in unpredictable behavior, crashes, or unindented modification to unrelated data. Avoiding the use of while pointers is very essential to prevent undefined behavior. So, the best practice to avoid these pitfalls is always initialize the pointers before using them to prevent undefined behavior and unexpected results. Check for null before dereferencing pointers to avoid crashes and handle cases where memory allocation fails. Properly free the dynamically allocated memory to prevent memory leaks and ensure the efficient memory management. So these are some of the best practices that we could include in our programming to avoid the common pitfalls. Concluding, pointers allows programs to request and release memories during runtime, providing flexibility in managing memory resources. So dynamic memory allocations primarily require pointers in their process. Pointers enable efficient manipulation of data by directly accessing and modifying memory locations, allowing for optimized algorithms and data structures. Passing addresses of variables to function allows modification to original data, facilitating more efficient parameter passing and data manipulation. The advantage of using pass by call by reference or pass by address is that any modification that happens in the call function will have a reflection in the calling function. Pointers are essential for implementing dynamic data structures like linked lists, trees, enabling which requires dynamic memory allocation and efficient data organization. So pointers play a very important role in all these scenarios. So in the upcoming section, we will discuss about the pointer arithmetic. So what are the various operations that could be performed on pointers? The next session, we will discuss in detail about dynamic memory allocation, which majorly plays with pointers. We have different functions defined in C programming under stdlib.h header file, which uses pointers in their syntax. We will also see how pointers are used with arrays and structures for efficient programming practice. Thank you.